in this problem, we are given that this equation has roots alpha, beta, gamma, delta, and we need to form a new equation whose roots are alpha plus 2, beta plus 2, gamma plus 2, or delta plus 2, that is increased by 2. Okay, so the main concept here that we need to know is that we need an equation in y whose roots are actually x plus 2. And now we can substitute this back in the equation in the form of x equals y minus 2, and we are going to get something like this. And so on. Now, this looks really simple to do, but it's going to be really calculation intensive, and we are not like inclined to do such calculations here. Now we are going to get something of this form: a naught y to the power 4 plus a1 y to the power 3 plus a2y. Now we can again substitute y equals x plus 2 here. And claim that these two are the same equation. Okay, I'm going to write the rest of the terms here. Now, notice that if I divide this equation by x plus 2, I'm going to get a4 as the remainder. Okay, that implies if I divide this equation by x plus 2, I'm going to get some remainder, and that is going to be equal to a4. So that is how we are going to calculate all the coefficients. Okay, whatever remains the quotient. Okay, let's suppose this expression a naught Now, clearly this is going to be the quotient, and if you see, again we divide the quotient by x plus 2, a3 is going to be the remainder. That means whatever quotient we get after dividing this expression by x plus 2, we can divide it again to get the term a3, then a2, then a1, then a0 by repeating the same process. In long divisions, I need to write a lot of things. So what I'm going to do is not use long division and use synthetic division. If you have not watched my video on synthetic division, please do watch it. So we find that a4 is actually going to be 9. Then again, these are the coefficient for the next equation. As you know, we are again going to divide this by 2. Next, we are again going to divide this expression. Again, we are going to divide this expression. And simply, this is going to be the leading coefficient, and that is a0. So we obtain that the equation is actually going to be 4y to the power 4 plus no a1 term. So we are going to go to the y square term, and then we see that there is no a3 term, that is there is no y term. So simply 9 equals 0. Okay, so we find this equation, and we see that this equation is solvable. Actually, we can go ahead and solve this. It's going to be y square minus 1 times 4y square minus 9. So y is going to be either plus minus 1 or plus minus 3 by 2. And hence we can find the root of the original equation as well, as we know that the roots of this equation is actually increased by 2. So yeah, so this is our final answer. That's it. Okay, so here we have the equation x cube plus bx plus q whose roots are alpha, beta, gamma, and we need to find the equation whose roots are alpha square plus beta square plus gamma square, and gamma square plus delta square. Now we see that this roots of the new equation are actually combination of roots of the old equation, and it's not in terms of purely one root of the previous equation. So what we are going to do is first bring that in terms of one root of the previous equation. So we can write alpha square plus beta square is actually equal to alpha plus beta whole square minus 2 alpha beta. And now using the root correlation with the coefficient, we can write alpha plus beta plus gamma equals 0. And alpha beta gamma is equal to minus q. I can write down Now we can see that we have brought down the first root in terms of purely gamma. Similarly, we can do that for the second and the third root as well. And we can write down now that we need an equation in y whose roots are actually x square plus 2q by x. Now, this is still not solvable because we can't write x as some expression in terms of only y. So we need to do further manipulations here. I'm going to write yx is equal to x cube plus 2q. Now I can see that x cube is the same x cube that satisfies this equation. So I can write x cube equals minus bx minus q. Now we can see that we have actually reduced everything in terms of y, and now we can substitute it back in the equation. We can further simplify it to get a polynomial in terms of y, which is going to be our equation whose roots are alpha square plus beta square plus gamma square, and gamma square plus delta square.